Today, we're diving deep into renal cell carcinoma, or RCC, but we're not going to just look at it like a textbook disease. No, we're going to unpack this incredible story of how just one tiny genetic mistake can completely hijack our body's own machinery, turning a vital organ into its own worst enemy.
All right, so here's our roadmap. We'll start with the basics. What even is kidney cancer? Then we'll look at who it affects and zoom right down to the molecular level to see how the hijack actually happens. From there, we'll get into how doctors classify and treat it, and then wrap things up by looking at the bigger picture and what the future might hold.
So, first things first, let's get our bearings and make sure we're all on the same page about what renal cell carcinoma actually is.
Okay, so RCC starts in the tiny tubes inside your kidneys. You know, the ones that do all the hard work of filtering your blood. And we're going to be focusing on the most common and frankly most aggressive type, clear cell RCC. Why the name? Well, it's pretty literal. Under a microscope, the cells look clear or pale. And that clear look, that's actually a huge clue about its unique biology, which we'll get into in just a bit.
Now let's zoom out a bit. How big of a problem is this really? Who does it affect? And what are the things that put someone at risk?
Just look at that number, nearly 500,000 new cases in a single year. This is absolutely not a rare disease. It's actually the 13th most common cause of cancer death around the world. And what's concerning is that the numbers have been ticking up, especially in developed countries. So yeah, this is a pretty significant global health challenge.
Now this is fascinating. This table tells a really important story about how this disease can look different in different parts of the world. If you look at the global data, the peak age is in the 60s. But then you look at data from Indonesia and bam, people are being diagnosed a whole decade younger. You also see that they're often showing up with more advanced disease, which really highlights how things like healthcare access and public awareness can make a huge difference.
So what's driving this? Well, there are some really well-known culprits. Lifestyle plays a massive role. Smoking tobacco, it literally doubles your risk. Obesity and high blood pressure are also major contributors. And then, of course, if you have other underlying kidney issues or, in rare cases, specific genetic conditions like von Hippel-Lindau disease, your risk goes way up.
And that mention of genetics is the perfect segue, because to really truly understand this cancer, we have to move past the stats and zoom way in, right inside the cell, because that's where the real drama, the molecular hijack, actually takes place. This brings us to the main character, or maybe the main villain in our story. A gene called von Hippel-Lindau, or VHL. Think of VHL as a guardian, a brake pedal for the cell. Its job is to prevent chaos. But in over 90% of clear cell RCC cases, this guardian is broken. It's mutated or just completely silenced.
And this right here is the whole story in a nutshell. It's a simple but absolutely devastating chain of events. Step 1. In a healthy cell, the VHL protein is the brake. Step 2, it keeps things in check by getting rid of a growth signal called HIF-alpha. But step 3, the VHL gene breaks. The brake pedal is gone. And step 4, that growth signal, HIF-alpha, builds up and up and up. It's like the accelerator's jammed to the floor. This tells the cell to grow uncontrollably and, this is key, to build a ton of new blood vessels to fuel its expansion. That's why these tumors are so rich in blood vessels.
Okay, so a tumor's been found, we understand the biology behind it. Now what? The next step is absolutely critical, figuring out exactly how serious the situation is. And for that, doctors need a system. As you can see, clear cell isn't the only game in town, but man, it is by far the most dominant player, making up about 3/4 of all cases. And its dominance is exactly why so much research is laser-focused on that broken VHL-HIF pathway we just talked about.
So, to classify the cancer, doctors around the world use what's called the TNM system. It's pretty straightforward. T is for tumor. How big is it and where is it? N is for nodes. Has it spread to any nearby lymph nodes? And M is for metastasis. Has it traveled to distant parts of the body? You put those 3 letters together and you get a precise stage. And that stage is probably the single most important factor for figuring out what to do next.
So, now that we know the enemy and how it's classified, how do we actually fight back against this cellular hijack? Well, the strategy completely depends on the stage of the disease. And here is the absolute bottom line. If the cancer is caught early, while it's still just inside the kidney, surgery is the one and only chance for a cure. The goal is simple: get it all out.
When it comes to the surgery itself, there are basically 2 main options. For smaller tumors, the surgeon will try to do a partial nephrectomy. just taking out the tumor and leaving as much healthy kidney as possible. But for bigger, more complex tumors, a radical nephrectomy, taking out the entire kidney, is often the safest bet to make sure no cancer cells are left behind. It's all about balancing that need to cure the cancer with preserving long-term kidney function.
But what happens when the cancer has already spread? Well, the game completely changes. Now the goal shifts from cure to control. And this is where modern medicine is just incredible. We have targeted therapies. These are smart drugs designed specifically to block the growth signals that broken VHL pathway is screaming out. We also have immunotherapy, which basically takes the brakes off your own immune system so it can go find and kill the cancer cells. It's amazing stuff.
All right, in our final section, let's pull the lens back one more time and look at the wider impact of RCC, because the effects of this cancer can actually ripple out way beyond just the kidney itself.
I just want you to sit with this number for a second. 8%. For patients whose cancer has spread, that's the 5-year survival rate. It's a brutal, sobering statistic, and it's exactly what drives the relentless, urgent search for better, more effective treatments.
Now here's something that is truly wild and can make diagnosis really tricky. Sometimes the tumor acts like its own little rogue hormone factory. In up to a third of patients, it starts pumping out substances that cause all these bizarre, body-wide effects. Things like sudden high blood pressure or making way too many red blood cells. It can even cause serious liver problems, known as Stauffer syndrome, even when the cancer hasn't spread to the liver at all.
You know, figuring out that whole VHL pathway, that wasn't just some academic exercise. It completely revolutionized how we treat kidney cancer and led directly to the targeted drugs we use today. And that leaves us with this really hopeful, powerful question for the future. As we get even better at decoding the genetics, can we one day create treatments so personalized, so precise, that they can stop this cellular hijack before it even really begins? That's the hope, and that's what drives the science forward.